Hello everybody, Rudy from IMC back once again with another Python tutorial. This time we're going to be looking at for loops, which are a different kind of loop in Python. They're specifically for looping over sort of structured sequences, so containers. So examples of this are things like lists, even strings, okay? But we'll get into it and we'll sort of see what their kind of main use is. So previously we've looked at while loops, right? And so let's say that we have a list with some numbers in it, okay? Previously, when we looked at using a while loop, we had to do something along the lines of this to get at each sort of element of our list, right? We set up this counter guy. We have to check while it's less than len numbers. We then have to access our element, and then we also have to remember to sort of increment our counter, right? Otherwise it sort of gets left behind. And so if I run this, we can see that it works, but there is sort of this whole I thing going on, this condition, this accessing of the list. It's a little bit cumbersome, and this is where for loops come in. So for loops are made specifically for looping over things like lists, anything that has like has a bunch of elements in like a defined order, right? A deterministic order. And so what a for loop looks like, let's just get this out of the way for the moment. For loop, much simpler syntax. For keyword, number in numbers. Okay, so what have I got here? So the for loop syntax is for variable name in, and then the thing that you want to loop over. Okay, so I've called this number and numbers. The name of this guy is fairly irrelevant, but I would encourage you to use a good name like this so that it sort of makes sense. And you'll see if I run this code, I actually get exactly the same output, but we've just done away with this I entirely. We didn't need to worry about when we hit the end of our list. We didn't have to access the element, right? That was all handled by the for loop, okay? So when we're doing something like looping over specifically a container, it's generally far more preferable to use a for loop than a while loop, just because it's so much cleaner and simpler. Sort of one thing I touched on before as well is that it's not just lists that we can loop over. Okay, all right, we can loop over other stuff as well. Let's say I have a string, Terry. Okay, I can then go. Right, and of course remembering that these variable names don't really matter, but that's why I've given them nice names so we can keep track of it. Terry, T-E-R-R-Y, right? Because if you think about it, a string is really just a structured sequence of sort of single characters, okay? So we can for loop over numbers, we can for loop over strings. There are a bunch of other data structures that we'll get to that you can for loop over as well, but yeah, essentially when you have this container, you need to loop over it. I very much recommend using the for loop instead of the while loop. So with that being said, let's jump over and see what Terry is up to today. Best part of the video every time. Big crates, big bunches, right? Terry lives large. So Terry has decided to invest in some bigger crates which can fit multiple bunches of bananas of any size. All right. In his haste to pack all of his banana bunches into these new crates, however, Terry forgot to count his overall total number of bananas. What he does have, though, is a list of his crates, which contains lists of the size of each banana bunch they contain. Okay, so that was wordy. We're getting bogged down in the lore a little bit, but what we essentially have is we have a list, right, of lists. Okay, so he has a list of his crates. So each of these guys is a crate. Okay, and each of those contains lists of the size of each banana bunch they contain. Okay, so there's the crate, and the crate contains a 25 banana bunch, 25 banana bunch, 25 banana bunch, and a 25 banana bunch. This crate contains a 40 bunch, a 45 bunch, and a 10 bunch. And this crate just has one big 90 banana bunch inside it. So what we're going to do is we're going to write a function, count bananas, which takes a single list argument, as we can see here, each element in this list is a list of integers representing a crate and the bunches of bananas within it. Cool. So the function should return the total sum of all integers. So what we've seen here is we want Terry to go through, we want to calculate that all these numbers added up, and this example is 285, okay? But this should work for any arbitrary number of lists within, like any number of crates and any number of banana bunches within those crates, okay? So you could do this with while loops. I would encourage you for today's exercise to try using for loops, as that is the purpose of the exercise. But it should be possible with both. So with that being said, I'm going to encourage you now, have a go with it, play around with your for loops. Feel free to try the while loop as well, but make sure you get used to using for loops too. And then I will be back in a few seconds with the solution. Alrighty, let's count some bananas. So our function is count bananas, okay, and it takes a single list argument, which is the representing our crates and the bunches of bananas within it. Okay, so I'm going to call this guy crates, and we're expecting this to be a list of lists like this down here. Cool. So what do I have to do actually? I have to look at each crate within the list of crates, and then within that guy as well, I then have to look at each bunch of bananas. Oh, my voice is all over the place today. Okay, so I guess the first thing I'm going to do is just try and access each individual bunch of bananas. Okay, so how do I get to this 25 essentially? Well, what do we have to do first? The first thing we have to do is we have to get into this first element, which is the list. And then within that list, we then have to get to the first element again, and then the second, etc. So if I wanted to look at just each crate on its own, right? Let's start with that. That's a bit more, that's a bit less abstract, okay? So how do I get to each crate? Well, this is a list. I want to look at each element in the list. So I'm going to use a for loop for we want something in crates here. Now each single one that we look at is going to be a singular crate, so I'm going to call it for crate in crates. Good variable names make life easier. And let's just print out that crate for the moment. Okay, and then I am going to try running this guy as well. So let's see how that goes. Okay, cool. So you can see that our for loop has taken each singular crate of bananas out of our big list. I was trying to think of an analogy. This is our warehouse or something. And we see we've got each of them now in the for loop. Cool. So now what I want to do is I actually want to look at each element inside this list. Okay. So this is where we start to get a bit fancy, a bit spicy. We're going to need another list. Okay. So let's keep that print there. And now I want to look at each. These are, I guess, banana bunches within the crate. So for bunch in crate, I guess. So for bunch of bananas in the crate. Let's now print out the bunch. Okay, I'm going to scroll down. Let's get a bit of room here. And when I run this, okay, look at that. So we print out the crate, and then we for loop again over each thing through the crate. So 25, 25, 25, 25. Then this loop ends, so we go back up to this loop, print the crate, and then for each element in that crate, 40, 45, 10, and even the 90, right? Notice how even when there's only one element in there, even when there's only one element in there, we can still loop through it and get that one element out, okay? And I guess just for a bit of curiosity here, see what also happens when I add, even if I have an empty list here, right? The for loop is actually smart enough to not even go into it. So notice that this print, right, is from us printing the crate. But then when we try to loop over it, right, Python goes, well, that's an empty guy, so I'm done. And it doesn't even, yeah, it just doesn't even run any of this, right? Because there's nothing to loop over. Just a little interesting tidbit there. So cool. So now what did we actually want? We wanted the overall total of bananas. So I'm going to clean up these that print a bit. So what do I want to do with this, with each of these numbers? I want to add this up to a running total and return that. So we've done something similar to this before, I think, but I'm going to set a total outside my loops, right? Because I want to keep the total, I want to set it once, and then as I work through every single one of these crates and bunches, I don't want to reset it, I just want to add to it. So I'm going to put that there. I am going to then add the size, or the number of bananas I have in each bunch, to that total. And let's get that total back right at the end. Okay, so now if I run this, I've still got all my prints. I'll clean that up in a second. But then I also have my big total here, and we can see that that's correct, all right? So we can nest our for loops like this, right? If we've got a nested structure, and just think about how sort of a bit cumbersome this would have been if I tried to use while loops, right? I would have had to use an I and maybe a J or another letter. I would have had to keep track of these two counters. I would have had like two I plus equal ones, J plus equal ones within the while loop. There would have just been a lot going on, and it would have just been quite icky. But with the for loops, we can see it's pretty easy, right? And even with nice variable names, it actually becomes pretty obvious what's going on. So yeah, back the for loop here. So let's just get rid of this print, and then now run that again. 285. Okay, so that's the count bananas. Now we've actually got a little bit more to go here. Ooh. Excuse me. Terry is also interested in knowing the biggest banana bunch he currently has in his crates. So create a modified version of your previous function, biggest bunch, which takes the same input, but instead returns the size of the biggest banana bunch. Okay, so same input, but instead we just want to know where was the biggest bunch of bananas, or I guess what was the biggest bunch of bananas. Okay, so this guy should be pretty similar to the last one. Give it a go, see how you go with it. I will be back in just a few seconds with the solution. Okay, we are back. Let's get back into this biggest bunch function. Biggest bunch. Now, this is actually quite similar to the last one, right? We want to still look at each bunch of bananas individually and do something just a little bit different there, but I am going to, crates. I am going to have very similar starting code for this, right? For crate in crates. Oh, I just keep wanting to create. It's just who I am, you know? For bunch in crate. And let's just go back to printing out the bunch, right? So let's just start with this again. Let's try running it. Cool, so we're back to looking at each bunch individually. Now, what did we want here? We wanted to return the size of the biggest banana bunch. So I guess what I have to do is, as I'm looking at each of these, I want to know if this is the biggest one. Okay, so how can I do that? I need some way of keeping track, because I suppose like as we start, right, we only see this, and then we see this, and then we see this, and then this, and then this, right? That's like the sort of the amount of stuff we've seen so far. So we kind of just want to keep track of the biggest one we've seen so far, right? Because by the time we get to the very end of the list, we'll have seen every banana bunch, right? And in this case, the biggest one is here, but that shouldn't really matter in the grand scheme of things. I might just add a 5 on the end of this as well, just to make sure that we sort of see what's happening here. So I need something that keeps track of the biggest banana bunch I've seen so far. Because what I essentially kind of want to have in my code here, right, is I'm gonna have a check, right? Is this bunch the biggest bunch so far? So how do I check that? I need to know if this bunch is the biggest so far. So let's just say I have something keeping track of this biggest guy so far. What do I want? If this bunch is bigger than the biggest bunch I've already seen already, then what do we know? Well, if it's bigger than everything we've seen so far, then bunch is actually the biggest one we've seen so far now, right? We sort of need to update our state. So in that case, the biggest one we've seen so far becomes the newest bunch, right? Now, if I try and run this code at the moment, okay, we're going to run into a little bit of a problem. Okay, and that is of course that, if I scroll down a bit so we can see the error, local variable biggest reference before assignment. So this classic error we got somewhere else as well before, where it doesn't know what biggest is yet, right? Because we've never assigned it. We've never gone biggest equals this. Okay. Now, we've got a couple of things we could do here. We need to set this to something, right? And we need to do it probably before we get into our loop. Because otherwise we're gonna, if we put it here, right? If we set biggest to be something here, it's gonna reset every time we go to a new crate. Okay, so we need something for biggest here. Now, if we're sort of thinking about this a little bit in terms of the real world application, right? It's a bunch of bananas. We can't really have a negative bunch of bananas. Okay, so the main thing that we want to ensure is that if we haven't seen any bananas yet, right, we want to make sure that the first one becomes the biggest one we've seen so far. All right, so when we look at that first 25, we need to go, cool, that's bigger than whatever I had before. So I'm going to set this guy to be 0 at the start. Okay, now since we can't have negative numbers here, right, like any number that we get is going to be bigger than 0. And otherwise, at the end of the day, when we finish and we return our biggest number, otherwise at that point in time, if we have no bananas at all, right, we'll just get the 0 back, I guess. But let's try looking at this, and there's our 90. So as a bit of a step through, let's say let's actually print out, or every time I suppose we find a new biggest, let's print it out just to get a bit of a better idea of when we go into this if. Okay, so let's see, we hit the first 25, right? And it went, so for crate, for bunch, so we're at the very first 25, and it went, is 25 bigger than 0? And it went, yep. So 25 is now the biggest guy. Print 25, there it is. And then we went through and we checked these three and we went, hey, is this bigger than 25? And we went, no. So then we hit the next crate, right? And we went back up to the loop and we went back through. 40, is 40 bigger than 25? Yes. So the biggest one is now 40. Print out 40. Same thing then happened with 45. Then we hit the 10 and we went, is the 10 bigger? No. Okay. And then finally in our last crate, we hit the 90 and we went, is 90 bigger? Yes. And then we hit the 5 and we went, is 5 bigger? No. Okay. If you're ever sort of struggling, prints are really helpful in these problems for like just keeping track of everything, what's actually going on with your code. So yeah, that's the biggest bunch of bananas there. And this has been for loops. Okay, so for loops, super useful when you're dealing with things like lists or other container structures. And I encourage you to get comfortable with them over while loops for those situations.